All right, here we go. 1.8 slope. All right, so first of all, what is slope? All right, slope is, let's write down the definition. Slope is the rate of change between two points. Okay, the rate of change between 2 points. So it's basically the same as rate of change. All right, that's what you have to understand is, yeah, it's the same deal as rate of change. It's just we call it slope because when you're talking about slope, you're not necessarily comparing. The difference is you're not necessarily comparing two quantities. It's not necessarily miles and hours or things like that. A lot of times it is, but sometimes it's just x and y, and sometimes that's what we're dealing with. Okay, so all right, so real simple. It's the same thing. It's still change in y over change in x, and we also call that rise over run. And actually, I wish I would have introduced that to you earlier, because that's the concept we're using. Rise over run. How much you go up and down. Okay, it could be fall. Okay, that's for negative ones. But how much you go up and how much you go over. Okay. So let's do. It's really simple today. Okay, let's just do a few examples together. All right, let's just make a little. Let's just make a little XY table here. And when you're dealing with slope, you only need 2 points. If to make a line, you only need 2 points, and that's it. 2 points. Right? Because you want to find the slope between 2 points, right? That's why when we were talking about yesterday, just find 2 good points. That's all we're referring to. So 2 good points. So let's just say, I'm just going to make some numbers here. Let's say 2, 10, and 4, 15. And then I'm going to draw a little graph here. All right, so let's go ahead and just make this. Again, your x is always this axis, right? This is your x, and this is your y. So let's just do the basic points. Here's 2. Here's 4. Let's go up by 5s on the side. 5, 10, 15. All right, and then let's go ahead and graph. Okay, so I'll use a different color for you guys. 210, 415. And then once you have those 2 dots, just connect the dots. And remember, don't just connect it and have your line be floating like this. Have it go all the way to the y-axis. Sorry, a little bit sloppy. Okay, so you want to find the slope of this line. Okay, first of all, proportional, yes or no? No, not going through the origin. Okay, is there a constant rate of change? Yes, if it's a straight line, it's a constant rate of change. Okay, if it was like not straight, if it was like going bumpy or something like that, it wouldn't be constant, but it's constant. Okay, so now we just find the slope from these 2 points. And this is what we do. We do the rise over the run. Well, that's exactly what we've been doing for the last 2 days. Okay, so again, we choose our 2 points. Sorry, I should use different colors. This point and this point. And we talk about the rise. So first thing is the rise. How much are we going up? This is going to be 5. Right? From 10 to 15. If this seems familiar, yeah, we did this yesterday. And then how much are we running? Okay. We are running 2. So our slope, okay.
Mr. Leon, how did you get 2?
I'm going from 2 to 4. Yeah, that's a great question, right? Sometimes you think, but Mr. Leon, I'm going over only one space, right? But remember, you have to look at the numbers. This is a 2 and this is a 4, so I'm going over a 2, right? Okay, so rise over run. So that means, simply, the answer is my slope is 5 over 2. That's it, okay? This time with slope, you keep it as an improper fraction, right? So basically, what we like about the improper fraction is this tells you like where my next point would be. Oh, up 5 over 2. So I know my next point would be up 5 and over 2. And that would be my next point on my graph. Okay? Up 5 over 2. That's what your slope says. So that's better than 2.5 if you would have divided it. Okay, so we're talking about slope. We're talking about lines mainly, and that's what we're trying to figure out. What is the slope of the line? Okay. Now remember, it's also the way we could have looked at it is it's the change in y compared to the change in x. So think about it. This is how we did rate of change, right? We said this is a change of 5, and change here is 2. So 5 over 2. Yeah. Change in y over change in x. 5 over 2. Pretty simple. Okay, let's have you guys do an example. I'll make this one a little bit tougher for you. All right, let's say you are someone who is planting a plant. Have you guys ever planted a plant before? Yeah, plants are fun, right? They're really exciting. They grow, and then you forget to water it, and then they die, and then it's sad, right? Oh, okay. But let's pretend like you're good at. Okay. Let's pretend that you are good at planting the plant. Okay. Oh, hold on. It looks like I might have frozen here. Can you guys hear me? Thumbs up, thumbs down. Okay, we're okay? Okay, sorry. I think it froze for a sec. Okay, all right, here we go. So let's say this is you are planting a plant, and every week you measure your plant. You measure the height of your plant. All right, so 1 week, 2 weeks, 3 weeks, 4 weeks, and this is 1.5, and this is in inches, okay? 3 inches, 4.5, and 6. These are all in inches. Sorry, go and copy that little table.
Mr. Leon,
Mm-hmm.
under the 2 is a 3, right?
Yes, that's a 3. Thank you for asking. Sorry about that. I'm not sure if that helped. Okay. All right. So I want you to graph this and find the slope. Graph it and find the slope. Now, the first thing that you might have trouble with is which one is your x and which one is your y. Okay, just think about it as like which depends on which. Which one do you think should be on your lower axis and which one should be on your upper axis? Excuse me. What do you guys think? Is weeks my x or my y?
X.
Joaquin says x. Correct answer is yes, that is your x. Okay. Generally, time is always going to be your x. Okay. Okay. Go and graph it. Find the slope. I'll give you guys a little head start. All right, I'm going to start drawing my graph, and you should see if your graph looks like mine. Okay, so this is weeks down here, and this is height. I'm going to do this in 1, 2, 3, 4, 5, and I need a 6. Okay. And don't worry, you don't have to graph on your IXL. They give you the graphs, but it's just good practice for us. Okay, and then for weeks, I'm going to do 1, 2, 3, 4. And then I'll plot my points. So between 1 and 2 is 1.5. If you want to do smaller numbers, you want to do the 0.5s, that's fine. On the left side, you can do that however you want. So I just know, okay, 1, 1.5, 2, 3, 3, 4.5, 4, 6. Okay, does your graph look like my graph? Yeah? Does your graph look like my graph? Hopefully you weren't waiting for me to draw my graph. All right, now, remember, we can choose any 2 points that we want. So I'm going to give you a big time hint right now. Don't choose decimals. Choose whole numbers. Yeah? If I have the choice between choosing any of these points, right? The ones that I'm going to choose to use to find slope are going to be this one and this one. Because that way I don't have to worry about decimals. Does that make sense? Right? Remember, we always talk about using good points. these are my best points. This one right here and this one right here. 2, 3, and 4, 6. But Mr. Young, are you allowed to skip a point? Yeah, remember, it doesn't matter. You can use any 2 points, any 2 points on the graph, and the numbers will come out the same. You might have to simplify, but you can use any 2 points. Okay? All right, so let's find our rise over run. So let's see how much we rose. So we go from here, we go up 1, 2, 3. And we go over, looks like 2. Yeah? So again, same thing as yesterday. This time, though, you just keep it as a fraction. Rise over run. The other way you can look at this, okay, and this is for future, this is going to be, you're going to deal with slope for like the rest of your math career, is if you think about it, the change in y was 6 and 3. So if I subtract, right, 6 minus 3, I get 3. And what about the run, the x? Well, in that case, it is 4 and 2. 4 minus 2 is equal to 2. See that? Okay, if you want to look at it from here, look, the difference between 3 and 6 is 3. The difference between 2 and 4 is 2. Still get 3 over 2. So there's so many different ways. They're all super related. In this case, it's proportional. It works out. Rate of change is constant, right? Example A, it wasn't. Sometimes it's not. But still, you could be able to find the slope, which is, again, basically the same thing as the constant rate of change, okay, that we learned about in 1-7. And that should be comforting for you because that means when you have a quiz, if I ask you for the rate of change or I ask you for the slope, you should be able to find it since we spent a lot of time working on both. That make sense? Okay.
So to change a number, you divide them, and the slope, you just keep it that way, right?
Yeah, that's one big difference. Sometimes they make you divide it. On the IXL, they'll tell you which one is which. The reason that we like slope to be kind of in fraction form is, again, because I like it because it helps you plot the points, right? You're not necessarily figuring out like how much something is changing. You're looking at the graph and saying what's the slope of the line. And then also the way you talk about slope is you talk about steepness. Like if something's growing really fast, it usually has a steeper slope. Or if it's growing really slow, you have like a slower slope. So it's really more talking about the graph than that rate of change, okay?